that we are going to do. Ciao to AB partner. We've been working on solving 1- and 2-step equations. What do we know about them? Obviously, remember we have how many rules for algebra? Same thing, right? 1 minute. Okay. All right, so there we have our basic principles of algebra. Good, that was a good little review. Today, transposition is the last thing that we need to know. It's the next thing that we're learning, and it's the last thing that we're actually going to be changing in terms of algebra. Anybody music? Anybody do music? Yeah, there's lots of people that do music. What does it mean to transpose? In music, what does it mean to transpose?
Like you do another note again, like another verse.
No.
I do it again.
In piano, it would be like theory, right? Like in your theory, you would at some point in time, depending on what grade you are in theory, you would have to transpose entire pieces of music. What do you do with it?
When you transpose the one note lower, the entire sheet or something, the entire the music goes one note lower, and then it kind of sounds different, but it also kind of sounds the same.
Okay. You could be changing the key. Yeah, what else?
Basically move it all up 1 octave or down 1 octave.
Yeah, so sometimes it's a whole octave that you're moving, so then it's not necessarily the key that's changing, it's just moving up an octave or down an octave, or else you can change it to the whole key. The point is that you're taking a note and you're moving it from one place to the next, but you're keeping the general sound of the music the same, right? The rhythm stays the same. The notes that you're playing, if you're changing it to a different key, it's going to sound a little bit different, but you can still tell that it's the same song. Okay? Same thing with algebra. We're going to be moving things from one side to the other. The process is going to look a little bit different, but you are still going to follow all of the same ideas that we've been working with. Treating both sides equally, undoing the equation, and getting the variable by itself. Okay? So transposition technically means to move across or to move over. Right? In music, we move it octaves or keys. In algebra, we're going to be moving it from the left side to the right. Okay, so as of yesterday, this is how your questions needed to look. So this is what we would have looked like, right? So we're trying to get rid of the 5, so I'm taking that 5 away. Whatever I do to the one side, I also have to do to the other. I'm left with 7w equals 42. Now I'm getting rid of the 7, so I'm dividing it here, I'm dividing it here, and I'm left with the answer. That's a lot of writing, right? I'm going to show you how to do it shorter. So here's what we're going to do. First thing that I want to get rid of, obviously, is the 5. I know you saw little glimpses of it. First thing that I want to get rid of is the 5, right? Wanted to get rid of the 5 yesterday first, still want to get rid of the 5 first today. How am I going to get rid of that 5? How am I going to get rid of it? Okay, except for now I don't really want to have that much writing. So I'm going to subtract 5 from this side. When I subtract 5 from this side, what am I going to be left with here? What am I going to be left with? If the 5 is gone, what am I left with?
47 minus 5.
Okay, on this side, however, I'm left with 7w. On this side, I'm left with 47 minus 5.
I knew it.
Uh-huh. Okay, so what I've taken is I've taken this opposite operation and I've just put it down here. So I'm no longer writing the opposite operation on the left side. I'm only writing it on the right. Okay? I'm left with here 7w equals what? What's 47 minus 5? 42. Okay? Still have something left to undo. What am I going to do to undo that? Because basically what I'm doing is I'm dividing by 7 here to cross that out. I'm going to be left with only the w on that side. but I still have to show it on this side. So by showing the opposite operation on this side only, I'm still treating both sides equally. I'm just not showing it on both sides anymore. Because that's a lot of writing. Yes, so we want to get less writing, so we're going to show it like this. So what's my W equal to? Yep, W is still equal to 6. Okay. Yes. It's not, because look at all this other stuff. I've now gotten rid, I don't have to write this anymore, and I don't have to write this anymore. I'm just showing the opposite operation on the other side. Still the same number of lines, but I don't have to worry. It makes it a little bit easier for us to line up our equal signs too, because we sometimes struggle with that when we're writing it like this, right? So this helps us line up our equal signs a little bit. So what you're going to do, the old way is written up here. Write the transposition way in your math notes. So see if you can do this one. Okay, we're going to do a couple more examples, I think, or at least one more. Just add a page here. Somebody give me an operation, multiplication or division. Yeah. So we're going to be multiplying. Somebody give me a number.
4.
Okay. Somebody give me a letter.
2.
Another operation, addition or subtraction.
Addition.
Okay, so what number am I going to be adding? 7. Solve. Okay. Another one. Somebody give me, this time we're going to be working with division. Somebody give me a variable. Give me a variable. Not over 9. We're not going to do A and 9 together because they look too similar. I know, you don't see it until all of a sudden you're trying to write it again. A number.
1.
No.
2. Yay.
Last time we worked with addition, so this time we're going to have a subtraction. What number am I going to be subtracting?
6.
Okay, good. Hands up if you think you can do this.
One more. Oh my god.
No, not one more. On your sheet. Okay, so we're working on page 7. There is a typo on page 7. It's supposed to be a 9. And if you know what that means, then you've already taken a look at this. So what we have on our example part right here, I have 2 times W minus 3 equals 9. The next line says 2 times W equals 3 plus 3. That first 3 needs to be a 9. Right, so this needs to be a 9 for your example, because if you're looking at that later on, you're wondering where that other 3 came from. I don't know where that other 3 came from. It should be a 9. Okay, you are going to do the 11 questions on here.
It's 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Math. 11.
11.
But I've already done that one.
It's only 12.
It's 11 questions, right? Because the one is
It's 4
done
times
for
3
you.
minus 1.
4 times 3 minus 1. 4x minus 1, the x becomes.
Oh.
Do that in the calculator. So you've got the rest of class to do this. 20 minutes to do 11 questions.
So it's like 2 minutes.